Fine. So today we'll see brute force technique, and the problem that for the brute force technique that we are going to see is string matching algorithm. Okay, so what first generally we'll see what is brute force is about. Okay, so brute force is a direct and straightforward technique for solving a problem in which all the possible ways or all possible solutions to given problem are generated. Okay, the thing is you will be just using that straightforward approach to find the solution. For example, linear search is a brute force technique. Okay, what happened in linear search? You just got an array. Okay, it had some element. Okay, if this is an array A. Okay, and it got some elements inside the array. And if I want, I have key in my hand. Okay, if the key element is 7, what happened? I just compared the key element with each element in an array. Okay, so first 7 is compared with 5, and after if 5 if the 7 is compared with 5. Okay, okay, if it is equal, then we'll say it will say the element to be searched is at the index. If not, if they are not equal, then it will be incremented. Okay, so we had some variables to increment, and we had declared the key with some variable, and we have compared the key with the index value. Likewise, we have that did. So the general methodology, what we did is we compared each element one by one, rather than we didn't boycott some steps to find the right element or right position of the element. For example, in binary search, what we did is we just directly, we didn't do a linear search, rather than we just divided the array into two halves, and based on the key element given, we generalized whether it is lesser or greater. And if it is lesser, the search was in the left side. If it is greater, the search was in right side, and we did that. Okay, so this technique is divide and conquer technique. Okay, the difference is, the thing is, brute force technique will go the normal way of finding an element. Okay, that is linear search. Okay, if I want to find some people from so if I want to find a notebook from you people, then I will search one by one to find. I will not randomly pick people to find the note. If the class of 63, I'll check every 63% to find the particular note. That is what linear search is. But binary search is, I just divide the class into left and right. If I have some doubt on girl side, then I'll go only to the to search. I'll do the search operation only among the girls, not to the boys. So this is my binary search approach. Okay, so this is what your this is what the difference actually. But the brute force actually works based on the linear search approach. That is, brute force is a straightforward approach. Okay, so the linear search is a function or a problem. Okay, so solution for a problem. The search is of a problem. For that, we are doing linearly to find an element. Okay, that is our solution. This linear search comes into the category of brute force approach. Okay, so brute force is a direct strike. For don't confuse between, don't think that brute force, linear force, and binary linear search and binary are confusing terms. Just remember, this is a technique that is applied on one search algorithm. Okay, divide and conquer is a technique that is applied on binary search algorithm. So remember in that way. Okay, so this is a technique that is applied on one problem statement. Okay, the problem is you want to search an element linearly. Okay, for that you are using brute force approach. Okay, so likewise, please remember, don't confuse. Okay, so it is a direct and straightforward technique of a problem solving in which all the possible ways or all possible solutions to give a problem to be generated. Okay, so the testing is validity for every single solution. Many problems solved in day-to-day life using brute force strategy. Okay, for example, exploring all paths to nearby market to find the minimum shortest path, arranging books in the rack using all possibilities in to optimize the rack space. Okay, so just we are checking whether we can arrange in this way or that way is also a brute force technique. We are not jumping right in the conclusion to arrange a particular way. We are just choosing ways one by one to find. We are not choosing randomly, rather than we are choosing every possible solution and finding the right answer. Okay, that is what brute force is. Okay, next is brute force searching. The sequence is search of list of array list or array begins at the beginning of array or list and continues until the item is found on entire list or array. This is the example that I told. Okay, this is the example for linear search algorithm. Okay, it is most common search algorithm and it does not require any domain knowledge. All that is required is state description, legal operator, the initial state, and description of the goal state. So if you know the start state, if you know the goal state is the key in your hand. Okay, key to be searched is your goal. Okay, we want to retrieve the key. We want to know which position the key was there. So that is your goal. Okay, if you know the start and the goal, then you can do your search easily. So we don't need any domain extra additional knowledge for doing this kind of searching technique. It searches all the position in the text between 0 to n minus 1 m. After each attempt, it shifts the pattern to right by exactly one position. If you're searching for n characters in a string of m, then it is take n cross n tries. Okay. So the thing is, just I'll tell you what this is about. Okay. Okay. So this we are talking about linear search algorithm. Okay. So we are just searching each element one by one until the key element is found. Okay. So this part tells you about your problem statement for your DAA brute force approaches string matching algorithm. Okay, algorithm. Okay, so what is string matching algorithm basically? Okay, so I'll take this whiteboard for you to teach. So string matching algorithm. Okay, so string matching algorithm can be solved. Sorry, for your syllabus, it is solved by using brute force approach. Okay, okay, so we know about brute force. It's a straightforward approach to solve a problem. Okay, so it doesn't pick randomly. It go and try all possible solutions in order to find the right solution. Okay, so if you know the initial and the goal state, you can easily find the solution for the problem. You don't need any domain knowledge in order to use brute force technique for your problem to solve. Okay, so the string matching algorithm is your problem statement. What is string matching algorithm? Okay, so what is string matching first? Okay, so first you'll have a string. Okay, for example, if you have a string called what I can take. Okay, um, I'll take this is your string. Okay, so random is your text, and the pattern is an. So what is my string matching algorithm is I want to find this particular pattern in the given text. If the pattern is found, it should return the index of the pattern, or if the pattern is not found, then it will not give me any output. Okay, or it should say that the pattern is not found in the text given. Okay, so the aim is, for example, okay, R A N D O M. If this is the text, okay, I want to compare, I want to take this pattern AN and I have to compare with each element in the array and I have to find the exact pattern in the given array or the given text. Okay, so by seeing it, so we can find the AN was present at the second position and the sorry array of 1 and array of 2. Okay, so the index value of my pattern is 1. Okay, by seeing we can find, but we are making a computer to do that work for us. Okay, since it's only 6-letter word, I can do it easily. But if there are lots and lots of words, okay, letters in the word, then it will take lot of time. It's not a human cannot complete that work. So we need we need computer to we need computer to do the work, and computer cannot do it by its own. We need to program it in order to do the work for us. Okay, so the approach we have taken to create the algorithm is brute force approach, and the okay, and this total concept is called as string matching algorithm. Okay, so the aim, I hope you understood the concept of string
Right.
matching algorithm. There will be a text, okay, text
Interstellar.
given and also the pattern given.
Interstellar. படமா?
Fine. So if the given text is given and the pattern is given, and if I want to find the particular pattern, I have to compare each element. It is like a searching technique. I have to search the required pattern in the given text, and I have to find the right position of the pattern given. Okay, from the text. Okay, so will okay. So the main algorithm of this so by seeing this itself, okay, so this is the algorithm. Okay, so what is the algorithm actually? First you have to, okay, so the algorithm for this technique is actually you have to compare. Okay, so first point is you have to compare the pattern with first character of. Okay, for example, here AN. So AN is taken. Okay, first letter of this A is compared with first letter of this text. This doesn't. This is not equal. So what you have to do, if this is not equal, you have to increment this part. Okay. So okay, if it is equal. Okay. So if it is equal, what you have to do? You have to, okay. If it is equal, okay, increment. Okay. So if it is equal, okay, so if A and R is equal, what you have to do? Okay, so fine, fine, fine. Okay, so what you have to do is first I'll do it again. Fine. The text is, and the pattern is A and N. Okay, so if this A and, okay, so what I'm, okay, so I just want to compare this pattern every time with the text given. So there will be a pointer here and there will be a pointer here. Okay, first this first letter and this first letter is compared. Okay, if they are equal, okay, if now in the given example, okay, they are not equal. So if they are not equal, what happens? Okay, you just have to increment the text pointer. Okay, because this word is not, this letter is not equal to this. Okay, so increment. Okay, so now in this pointer, the text pointer will be in this position. Again you check, yes, they are equal. If they are equal, okay, so if first character of each character, okay, text, if they are equal. If not equal, then you, okay, then you have to increment the text pointer. If they are equal, what you have to do? If A and A are equal, so what you have to do? Then you have to increment pattern pointer, because I should not stop my comparison only with the first letter. I have to compare whether this letter is also available in the text, because I have to match this entire string with the string in the from the text, right? So since this A and A is matching, I should not stop it. I have to go for the next letter in the pattern. So I have incremented my pattern now, pattern pointer now. So my pattern pointer is at this position. Now it is comparing with this, the next letter in the text also, pattern, increment pattern pointer and text pointer. Okay, so if now n and n is compared, if both are equal, then you have to tell the index, return index. Okay, or else you just return -1. Okay, so I hope you are understanding the algorithm work. Okay, so how this algorithm actually work is, first you compare the first element of text and first element of the pattern. Okay, so this, okay, first here, since there are only two elements in this pattern, I'll have two increment in pattern part, and I can have n minus m increment in the upper part. Okay, so so here the number of letters considers n, and the number of letters in the pattern is considered as m. Okay, so n represents number of elements in text and m represents number of elements in the pattern. Okay, so the pattern comparison will start with, for example, if pattern is set as j and text is set as I, so my pointer, okay, the pattern pointer is j and text pointer is I, my pattern pointer, this comparison will start from, okay, start from j is equal to 0 to how long the length of my pattern, what is my length of my pattern is m. Okay, okay, fine. Till m, my comparison will be. If my text has pointer as I and it starts from 0th index to how long? To I is equal to n minus m. Why n minus m? Because if you are removing n, if you're doing n minus m, you'll get the right word. Okay, because m is the pattern and n number of words. Okay, if you remove m that is pattern from your text, then that will be your number of comparison. That is what it is given here. It is not n minus 1 or n minus 2, it is n minus m, because we are exactly removing or finding the index of m, that is pattern in the text n. Okay, so that is what. Okay, so now so the thing is, we are having two pointers I and j. Okay, I is a pointer in text and j is the pointer in pattern, and we are comparing the 0th position of pattern and the text first. If they are equal, okay, here in the example given, they are not equal. So what you are doing, you are incrementing the text pointer itself. Okay, so now you are incrementing the text pointer itself. Again, you are comparing. Okay, so now you are comparing this I is equal to, now the value of I is equal to 1. Okay, so 1 for I is equal to 1, you are comparing the pattern for j is equal to 0 and j is equal to 1. So you are not only comparing only one element, for j is equal to 0 is a, and you are comparing a with I is equal to 1. I is equal to 1 is a. So you are comparing a and a here. They are equal. So increment j. Okay, now this is the next value. Okay, next j is equal to, if j is incremental, your pointer will come to this position, and you're comparing this with the next element in I. Okay, so this is also equal. So you're compare, if they are equal, you're incrementing both I and j. If not, you're incrementing only j element, and you're checking whether you have finding any pattern in the given text. Okay, so this is the algorithm. If you're getting the pattern properly, then you are returning the index. If not, you're returning -1. You're just telling your element, or you can also say the element is not found, or the pattern, the string is not matched. Okay, string is not matched. Okay, you can also say in this way. Okay, so this is how you can do this algorithm. Okay, so we'll see the coding part. Okay, so I have taken basic Python code. So we'll be through this algorithm we'll start doing the this part. We'll check the working of algorithm, this procoding as well as the example. Okay, so please listen carefully. Fine. So we'll start. Fine. So first we are, since it's we need to do this continuously, we are declaring of the function. Okay, so the function, just use this match as the function name, and I have started. Okay, the text and pattern are the given text and pattern. So the text I'm taking again as t is equal to random, and the pattern that I have taken is an. Okay, so you are just defining the text and pattern, and n represents the, okay, this is equal to n and this is equal to m. So what is the value of n here? 6. And what is the value of m is 2. Okay, there are 6 letters in text and there are 2 letters in the pattern. Okay, then for I is equal, so now you are starting your so you're initializing the pointer for text. Okay, so I is the pointer. Okay, and it ranges from 0 to n minus m. I told you why it is n minus m, and it is j is the pointer for pattern. Okay, so here starting from, so the j starts from 0th index and it will go till m, because m is equal to 2. It will go till the value of m. So there are only two elements, so it will go to for only two elements only. Okay. So first now we are checking, okay, whether, okay, if this is the main part, okay, where you are doing your logical part of your string matching algorithm. Okay, so what is happening here? If text of I plus j. So what is the value of I? So I is at 0th position and j is at 0th position, right? So if text of what is, just t represent text, okay, t of 0 plus 0, 0 plus 0 is equal to t represent pattern of, okay, so now I'll just take it, okay, fine, fine. So first now value of I is equal to 0, value of j is equal to 0, okay, because now I is at 0th position, j is at 0, okay, that is I is equal to 0, it goes till j is equal to, so I is equal to n minus m, okay, and j is equal to 0, it goes till j is equal to 2, because j range in m only, so value of m is equal to 2, okay. So I is equal to 0, j is equal to 0. Now we have to check, we have to do this analysis part, okay. So text of, okay, text of I is 0, j is 0 is equal to pattern of j. What is j? 0. So what is happening is text of 0 is compared with pattern of 0th position. Okay, so I, this is, and this is compared. Is it equal? No, this result, this is not equal. So this is false statement. So if it is false, you have, what you have to do, you have to increment C of, so C just increment. This is used for incrementing. Okay, now j is equal to 1. Okay, so j is equal to 1. Now text of, okay, I is still 0. Okay, now j alone incremented. J is 1, so 0 plus 1 and is equal to p of 1 is compared. Whether we are checking whether this and this is equal. No, it is not equal. So it is just exceeding the this loop. This j loop is exited. Okay, now we are incrementing the value of I. Okay, now I is 1, j is still, again it is coming back to this loop, okay, so j will be 0, so this I is 1, so this position, okay, this position and this position is compared, they are equal. So what you are doing, you are just increasing the count c value as j is equal to 1. So now you are checking I is equal to, sorry, if it is equal, then you are incrementing this I also. I will be now 2, I is equal to 2, okay, and that value and this values j is equal to 0 is compared, they are not equal, j is 1 is compared and they are equal. So what you will return, if c is equal to m, okay, if they are equal, then you are returning I, or else you are returning -1. Okay, so this is how your string matching algorithm is working. That is, you are just comparing by seeing itself, you are just taking whether you are just, how it works actually is, first you are comparing these two first, okay, this two, they are not equal, so you are just removing this first letter, you are just comparing these two, yes, they are equal. Next you are taking second letter and you're comparing with this letter, they are equal, so the match is found. Okay, so again you are taking this value with this and this, checking again, likewise you are keep on comparing each letter with the pattern and with the text letter again and again to find the matching. Okay, so actually they are using this kind of algorithm in biology, okay, for gene matching something. Okay, so this is the technique. Okay, so I have given a PPT, okay, a PPT with the example how this actually works, how this incremented and how they are compared. Okay, so this is the text. Okay, so this is the text and this is the pattern, and we are checking, so that the random and an is the simplest example, but you generally you'll have this kind of strings and this will be your pattern, and you have to compare whether this particular pattern is available in the given string or not. So I have it's not animated, but it's just picturized in this, illustrated in this way. Okay, so when you go through the slide, you'll understand how it actually work, and at the end the pattern was found at the index 10. Okay, so from this, so it will Generally, it will give you the start index of the pattern. Okay, because we know the length of the pattern. So if we know the start index, we obviously know based on the length, how long the index will be. So generally, it will start with the start index. Okay, the pattern retrieved will be at the retrieval index will be a start index. Okay, so next, finally, brute force. Okay, so this is the algorithm we saw. It is also known as substring match. Okay, every position of the given text do the next m element of the array. Okay, so same thing I have told you, and the time complexity is m into n minus m plus 1, and which is big O of mn. Okay, it takes big O of mn time to find. So based on the length of your text and the pattern, it will take time. Okay, and where m is equal to the mod of p and mod of t. Okay, we all know this. Okay, so the time complexity of string matching algorithm is brute force string matching is big O of m and n. Okay, the advantages are the guarantee way to find the correct solution by listing all possible solutions, because we are comparing each and every letter. So it is guaranteed that we'll get the right position, right answer if the string is available. Okay, if the pattern is available in the string. If it is ideal for solving small and simpler problem, it can consider as comparison benchmark to solve simple problem. Does not require any particular domain knowledge. Okay, so based on this algorithm, if you know how to solve this algorithm, then based on this benchmark, we can produce or create more algorithms. Okay, so disadvantage is it is efficient. It is an inefficient algorithm as it requires solving each and every state. It is very slow algorithm to find the correct solution as it solves each state without considering whether solution is feasible or not. The brute force technique algorithm is neither constructive nor creative as compared to other algorithms. So this is just an waste algorithm. It's not like waste, but it is just a general algorithm we use in our day-to-day life, and that is used to solve this particular brute force algorithm is used to solve a string matching problem. Okay, if you want to compare two strings and find at which index the string is there, you can use brute force techniques to find the right position of the string. Okay, I hope you understood this class.